Hey everybody, at this point I'm assuming that you've either ordered your RGB to HDMI parts or you are interested in ordering them and want to learn more. So what I want to do is I just want to step through what you get when you order your parts and what you need to do to get up and running. So let's just see what's in a typical package. So you'll get a package like this. It may be in a pouch or it may be in a small box. I'm testing out different packaging types here, but in this case I just have a small pouch here. So you get this, you open it up and take a look inside. This is one of the things you may have ordered, which is a case. Here is the adapter, and in this case it's also an analog board in the same package. And last but not least, we have the cable bundle. So let's just go through and see what these things are. Let's start with the adapter itself. It's going to come in one of these anti-static bags, and when you take it out, you'll see the board itself. And in this case I have the main board itself, and for this particular order I've included the analog board, and when you do that I typically ship them together so that they'll travel better that way. So the analog board is already attached to the main board, but that can be easily removed simply by pulling up or pushing this end of the board apart. There's a little header pin under here that will snap apart, so you just pull these boards apart on this end, and then you can slide the analog board off of the main board or the digital board here. But that's what you will see. If you didn't order an analog board, then you'll just get this top piece here, the digital board. So that's that. There's also the cable bundle, as I call it. So what I do is I make a cable that I test myself with a 9-pin DB9 connector on this end, and the cable that you need on this end to go with the that attaches to the digital board once the analog is removed. That just will slide in to the back like that. And then the other part would connect to a PC, and this supports MDA, CGA, or EGA. The reason I do that is because that's what most people want to use the board for, I found, at least here in the States. I know over in the UK, if you order this on the forum over on the original project, there's an ordering forum. If you order there, I think he typically ships with the connections for the BBC Micro. But because more people want to use this for the PC, over here in the States, I ship with a cable that should be used with that. So that's one cable, and then whether or not you ordered the analog board, you get this other one which goes to the analog board normally, and that just plugs into the connector on the end of the analog board, and then it's up to you to do whatever you want with it. Because all the pinouts are different for the various YUV analog connections for the various computers, I've just left this part here so that you can make your own end to go on whatever computer you want to get your analog signal for. And you should take a look at the cables section on the wiki, because that has the pinouts for all the various computers that this has been tested with so far, or at least most of them. So you can see an example here of an analog cable that I made for, I believe this was the Apple IIc maybe, or maybe this was actually this was the Coco 3. So here's one that I made for the Coco 3, and I had to do some modifications. This could have been done down here on this end, but anyway, just because there's so much variance in what the way that you hook this up for the various analog connections, I left this up to you to figure out what to do with. Last but not least, we have a case. Whether you may have ordered one of these cases. This is kind of a flub or reject, which is why I'm using it now, but it won't look quite like this. Hopefully it'll look a little bit better. So this was one of the early ones that I was practicing on, trying to get the distances right and everything, so I just thought I'd use this to demonstrate. But if you ordered one of these cases, when you open the case up, there should be some hardware on the inside that you'll need to take out, and these are the screws that you'll need to mount the Raspberry Pi and the adapter. When the adapter is plugged in, you'll need to use these to mount the board. So in order to mount this whole thing in the case, you start with this disconnected, put your Raspberry Pi in and use these smaller screws to mount to the back here. There's 2 holes in the back. That's where you're going to use those smaller screws. This plastic is very soft and it does strip very easily, so just be careful not to overdo it. Once you've got it kind of tight, you kind of check it, make sure it's snug, but don't over tighten these little screws because they will strip out that plastic really easily. Okay, once you've got that done, you can mount these standoffs to the front of the, or what I call the front anyway, where the buttons are. You can mount that underneath through these holes here. And all these are going to do is they're just going to take some of the pressure off when you're pressing down on these buttons. They're going to take some of the pressure off the so that this doesn't bend or move around inside the case. So once you've got that done, you can put these together. Make sure it's down all the way like that. And you can see this is very solid now. And then this top cover will go over that. And it should click into place. There we go. So there you have it. You still have access to your buttons. You can see the LEDs coming through here, and you can connect, in this case, the analog board. This connector for the analog board will stick out a little bit, so you can connect your analog cable. If you didn't order an analog board, then the other cable that connects to the main board would just slide through this hole here and connect up inside there. So there you go. Nice little case, and you don't have to worry about shorting out any of your connections as you're using it on your bench or around any of your other electronics. Okay, so let's talk about what's not included with any of these kits, and that is the Raspberry Pi Zero itself. The Raspberry Pi Zero is a $5 mini computer or single board computer, and you can get this on Adafruit or lots of other sites around the internet. There's typically you can only order one of these at a time. So if sometimes you can order one with headers, without headers. Sometimes you can get 2 that way. But anyway, you're going to need one of these because I do not supply these with your order. And then you're also going to need an SD card. Now you can use whatever size you want, down 8 gig, 16 gig, whatever you can get your hands on. You don't have to go any higher than that because the files you're going to put on here are a lot smaller than this card can hold. So you're going to have to supply those yourself. The other thing you're going to have to do, if you haven't done it already, make sure you have a header installed. This 40-pin header needs to be installed so that this has some place to plug in. And there's 2 extra pins. Now, these are optional, but what these do on the board over here, this button off to the side is a reset button. And you can use that to reset the device. So you don't need to use this necessarily because you can just use the built-in menu functions to do a reset if you need to. So if this button isn't working, or if you don't really care about that functionality, then you can avoid putting those headers on. You don't have to put them on. But to make it easy, you can just add 2 headers right there on this side of the Raspberry Pi Zero, and you just put them in right there. And the holes closest to the other header, there's actually 4 holes here, but you want to put them in the holes that are closest to the longer pin header, and then that will match up with the ones that come with the adapter. So you've got a female 40-pin header here, and then you've got an extra 2 little female pin header there, which matches up with this. So once you do that, then you can use this reset button, and it'll just do a power reset of the device. So that's something else to keep in mind. Okay, let's talk about getting the software set up that you're going to need to run this. Before we do, I just wanted to show you the cables page. Like I said, this is on the GitHub page in the wiki. If you go there, you'll see cables over here to the side, and you can click on that. It'll bring you to this page. And then you can scroll down and down and down for all the different types of connections that you can make. Anytime you see RGB, TTL, for example, then you need the main board for that. If I scroll down a little bit further, let's see, I should be able to find a Here we go. Here's analog RGB. So you know you need the analog board for that. So for example, for the Tandy Color Computer 3, you're going to need the analog board, 48K Spectrum. You know, some of these systems you can hook up either via analog or digital, your choice. So just keep in mind as you're looking for these cable pinouts, it's also a good way to see whether you're going to need the analog board or the main board or the digital board to make your particular computer work with this adapter. Anyway, I just wanted to show you that. So the other thing I wanted to show you is how you download the software. So you're going to start out with a blank SD card, and then you're going to go to the GitHub page and go to the code. So once you're on the main GitHub page, you can go over here on the right and you'll see the releases, and you can click on one of those. This will give you the latest release, at least on this page. And if you scroll down to the bottom, you'll see the actual downloads that you need. You don't need the source code. You need this zip file up here. These are the finalized compiled files that you're going to need. So you just click on that and download it to wherever you'd like to download it. And then you want to open up the zip file, and you'll see all of these files here inside that zip file, and these need to be extracted to your SD card. And it's basically, the first step is as simple as that. You just extract all of these files onto your blank SD card, and make sure it's finalized, eject that SD card, and then you can put that SD card in your Raspberry Pi Zero that you're going to attach the RGB to HDMI adapter to. Okay, the next step is pretty easy. You just take your SD card, put it back in your Raspberry Pi, and then you can attach the adapter to the Raspberry Pi itself. So the first time you power this up, it will have some version of the CPLD firmware loaded on it. So what you just put in the Raspberry Pi is the software that's going to run the Raspberry Pi part. However, the CPLD up here still needs to be programmed. Now, when I do testing on this, I actually program the CPLD to make sure it can be programmed, and I test it with analog and digital signals to make sure that everything is working correctly. However, there's no guarantee what I loaded on here last, so you can't guarantee, for example, that the digital firmware has been loaded or the analog firmware has been loaded to the CPLD. Luckily, inside the firmware, the software that's running on the Raspberry Pi, is a program that will upload the CPLD firmware for you, and you can upload it again and again to change the personality or just update the firmware if there's like some sort of bug fix or something like that. So really, really neat way to make it really easy to update the firmware on the CPLD just using the Raspberry Pi itself. Okay, so let me reboot this so you can see what it looks like when you first plug it in. So you'll get this 4-color pattern, and then it'll come up, and usually it will tell you what resolution it's detected and what profile it's using. So you can see here that actually the last time I used this particular board, I was using it on a Tandy Coco 1. So if I was attached to a Tandy Coco 1, that would be great. But what if you're attached to a PC? Then what do you do? The Tandy Coco 1 happens to be analog, and it's using the analog board. What if I don't have an analog board? I just have the digital main board, and I want to attach this to a PC. That's going to be a problem. So what you need to do is you need to go in the menu and reprogram the CPLD. So I'm not going to go over all of the features of the board and what these buttons can do, but just to give you an idea, the reset button that I talked about before is all the way over here. And then switch 1 is kind of like your activity button, and then the other 2 buttons are going to be up and down. There's more functions. If you hold down certain buttons, it takes a screenshot, for example. I'll let you go to the GitHub and the wiki page and figure out those details for yourself. But in terms of programming, once you get this board up and running, you're going to want to hit this switch 1, this activity switch first, and that will bring up the menu. So that brings up the main menu, and if we go use the other 2 buttons, the up and down button, to go down a little bit, you can see one of the entries here is update the CPLD menu. So I can hit that, and then let's say I wanted to use this on a PC. You can see there's 3 different types of firmware that are included here. There's the BBC. So if you're doing a BBC micro, that would probably be the one you'd want to use. But then there's also RGB. That is the main board, using the main board only for like with a PC or some other digital RGB connection to a computer. And then there is the YUV, which is the analog YUV signal that would be coming from a computer that puts out analog YUV or analog RGB. You would use that firmware. So let's pretend like we're going to hook this up to a PC and we need to reprogram the CPLD for that. So a PC is going to use the RGB, the digital RGB firmware for the CPLD. So we just hit the activate button or action button, whatever you want to call that button, switch one on that, and it'll say, hey, look, you're currently programmed for this firmware. Do you really want to overwrite this with the other one? Hit it again to confirm. It'll erase the CPLD and then it'll reprogram it. It takes about 10 seconds. And then it will say it was successful, hopefully, and it will reboot in 5 seconds. Now, when this comes up, it will look different. You'll still get that little rainbow pattern. Now it's actually up, and it's the profile is an Amstrad CPC. Well, actually, I forgot I had the analog board in there. When you have the analog board in there, you can't program it for a digital computer. It will auto detect that you have the analog board attached. So this thing is too smart for its own good. So I ran in and got a digital only, or just the main board without the analog board. So anyway, now you can scroll down to the profile here. You can use the buttons to scroll down to the profile. And let's say we were doing PC. We can just scroll down until we find the correct PC profile that we're using. So if you're using CGA, there's currently a profile for CGA, and if you're using EGA, there's a separate profile for EGA. So once you've got that profile set, you're good to go. Now, you may not even have to change the profile. I'm just showing you how to do it here, but it should auto detect. More likely than not, it will auto detect which PC you have connected to it. So that's why you want to turn on your computer. Preferably, if you're powering the device separately, you want to turn on your computer first and then turn on the adapter, and that should go in and auto detect. It has very good auto detect capabilities. It'll auto detect what it's connected to and pull up the right profile. But if it doesn't, you can just use the menu and change it. So there's lots of settings in here. The only other one I want to show you, and then you're on your own, is the auto calibration video sampling. So let's just go ahead and go up to that. The reason you would want to do this is if you were seeing some slight flickering on the screen, it could be that the sampling isn't set correctly and there's some errors that are creeping in. And so what you want to do is you just want to go up to that. The first thing I always do is make sure you're on a steady screen. So like for a PC, you would be at the command prompt. Hopefully the command prompt isn't blinking. That might throw things off a little bit, but you want a static screen. If you can get to a static screen, that is perfect. And then you just hit the auto calibration. It'll say press again to confirm. We can do that. In this case, it's not really plugged up to anything, so it's just going to get no errors at all because there's no signal coming in. But it'll just run through this. Again, it takes about 10 seconds to run through all the different sampling phases, and that just picks the one with the least amount of errors, and then it sets that for you so that hopefully it'll clear up any of those little tiny glitches that you might see on the screen. After that, you should be good to go. So that is it. I hope you enjoy your RGB to HDMI adapter and various accessories. I hope you have a lot of fun with it. I know I have. Check out the videos that I have done and the videos that other YouTubers have done on this board. It'll help you out a lot with learning how to use it, and be sure to go to the GitHub page and ask questions in the support forum that's linked on my store page, or you can find it in the GitHub page itself. All right, see you later.